All right, we're keeping our focus into the final stretch here. It's an honor to introduce Hadar and Markus, who are going to be talking about the end of the language barrier. So take it away.
Thank you. I'm here mostly to introduce Markus, but I wanted to kind of give a slight perspective, historical perspective on MT from a personal journey point of view. This is kind of a synopsis of my career with the machine translation stations, starting very, like 40-some years ago. I was never as deep as Markus has gotten into the field, especially because I feel like we started with a paradigm that was not going to work, which I'll get to in a second. But a few things that prepared me for thinking about it. One of them is my current role is dealing with multilinguality in Gemini, which is the Google AI, more broadly, which includes translation. Also about language inclusivity, where we think about how to open up the world to many, many languages and many modalities, including ASL, including other ways of speaking and communicating. Before that, I was leading the speech synthesis effort in Google, which is in itself a translation task from text to speech, dealing with all the underrepresentation, very similar problem. So what characterizes the early paradigms of MT? Essentially, there was a baked-in assumption that was not really challenged. I mean, it took a long time to challenge it because the circumstance of challenging it did not arise yet. But the idea was, in order to translate, you need to know what it is that you're translating. What is the meaning of the text? And meaning needed to be established at the word level. Each word, what does it mean? How do they come together? What is the syntax? How the syntax and the composition of meaning work? What is the semantics, which is some kind of a more abstract representation than the individual syntax of a given language. And each one of these was presumed to be mapped from the source language to the target language, such that you do analysis all the way up, and you do generation all the way down that pyramid with arrows going across to kind of inform each level of the original text and how it was conveyed. Of course, when you do it that way, each level of analysis has its own ambiguity, uncertainty, underspecification, and the ambiguity compounds. One of the most important problems then was to disambiguate. And disambiguation is really, really hard. And that enterprise essentially did not bear much fruit. It started in the 50s. The two languages that people worked on for 20 years were Russian and English for obvious reasons. In 1966, there was a report that an organization such as DARPA, but not DARPA, some predecessor of DARPA, commissioned called the ALPAC report, which essentially said, stop all the funding, this is useless, it's not going anywhere. And the field went dormant for 10, 20 years. It came back in the 80s. The paradigm still did not shift. We still did not have the machinery and the circumstances to be thinking about the problem the way we do now, when it is practically solved. So if you look at it today, it turns out that surface level is all you need if you have a powerful machinery to establish correlations, especially second level and third level correlations that are not obvious from the surface, provided you have the right data to learn from, which, you know, what is a talk about translation that doesn't have the Rosetta Stone? So I stuck the Rosetta Stone here. Very specific and fortuitous object, because it is parallel text of two languages, one of which is written in two different scripts. So it's kind of the ideal, now we know from what we're doing now, this is like the ideal data for breaking code or understanding language. from all I heard during during this workshop, we wish we had something like that for dolphins. We don't, or whales. Anyway, today's leading models are based on LLM transformers. They're massively multilingual. In my capacity as the language inclusivity director, we grew up the number of covered languages to above 200, somewhere between 200 and 300 languages. We currently translate on Google Translate, and it's getting easier. So we mentioned it yesterday about the fact that when the model itself is multilingual, you don't need as much data because something about the capability of encoding the same content from one language to the other, there is something innate about it that is learned almost orthogonally to the details of the language itself. I'm kind of waving my hands here knowingly. But the truth of the matter is that we can use far fewer amount of parallel data to actually accomplish the acquisition of a new language or a new language pair. And today's models are also multimodal. So speech and text can be used almost interchangeably. And we can also correlate one encoding with video, which is what opens up the possibility for ASL translation. So it's fascinating times. When I did my PhD 30-some years ago, my advisor, who was a well-known figure in machine translation, told me, look, we're not going to solve it in our lifetime, but it's about the journey. We will learn a lot along the way. And that was the mindset, and it was good enough for me intellectually. As it happens yesterday in Microsoft's, the event where they announced numbers, there was a question about what job you think is going to be taken by AI and in what order. They said, well, translators will go first. We don't need them anymore. So it seems like it's a solved problem. Of course, this is a bold statement, and Markus will show us that it's not quite true, and it's a great time to invite him to give the rest of the talk.
All right, thank you. Is the mic on? Yeah, awesome. First of all, thanks for inviting me. This is really, really exciting. I tell you why it's exciting, okay? Around the time, before I introduce myself, okay, let me give a small story about myself. When unsupervised machine translation came out, when was this, 2017, 18? There were a couple of startups who actually wanted to do like animal translations. And a couple of these startups back then reached out to me and said, do you want to join our team? Do you want to lead the machine learning group there? Right? You know a lot about translation, so you are the perfect candidate. Back then I said, like, okay, this is fun, but machine translation of human languages is not even as close of solvable. So this is a little bit too early, so let's focus on human translation before we actually think about anything like this. During the pandemic, me and my family, we made the bold move that we actually moved to Hawaii because we were locked into our house in California, and we said, like, okay, we are stuck here. Let's go to Hawaii. There we can hang out at the beach, right? And during that time, I really fall in love with whales because you could just lay in the water and you could hear them singing for like a couple of months. And you were sitting at the beach and you saw like all the waves jumping off of the water. And during that time, I always remembered with one of the guys I talked to, maybe it was one of you, they talked about like whale translation. And it always stuck in my mind. I said, like, maybe I did something wrong. I made a wrong decision, right? Maybe, maybe not. All right. So then, roughly a year ago, so I did my PhD in Germany. A lot of my peers work for companies like Amazon, Apple, all based here in Silicon Valley, but they don't live here. But they come here every year once, and we meet all together. And a year ago, I was like, you know what? We should work on whale translation. Everyone was laughing. Everyone was laughing, like, what's going on? And but then everyone followed up and said, like, maybe that's possible, right? And then I had a meeting. We worked on JAMA, and I sat together with the PM, Tris, and we talked about the project. And then he interrupted me like 5 minutes in and said, like, I have to show you something. You work on translation, right? I have to show you something. So he showed me like JAMA Dolphin, where we heard a little bit about already. And I said, interesting. So now Google is working on this. So maybe now it's the time, right? And then I kept fascinating. And then Hadar, a week ago, said, like, you know what? I don't know if he ever talked about whale translation. Maybe we did. I don't know. But he said, like, oh, yeah, I'm getting invited here. Do you want to give a talk together with me? I said, like, yes, hell, yeah, let's do it, right? So I had around a week to prepare myself for the talk. I just came back from Europe yesterday night because there's currently the conference of ACL, Computer Linguistic. And like I said, all my peers, I met them there, and we were sitting in a bar on the first evening, and I said, you know where I'm going? No, I said, like, Wednesday I leave already early because I have to go to Berkeley to give a talk. And I said, why? Why are you doing this, right? And I said, like, there is a workshop that also talks about, like, whale translation. And again, everyone was laughing, like, this is serious? Like 1 year ago, you talked about this, and now you're giving a talk there? It's like, yeah. And again, like, everyone was laughing. But then afterwards, like, the next 2 days, everyone was approaching me with, like, ideas how we can actually do this. So everyone is really fascinated about this. All right, so this is a short story. My background, I did my PhD in Aachen, in Germany, so I'm actually German. My PhD topic was machine translation system combination. Then I moved over to New York, to IBM. I worked there on the process between phrase-based machine translation to neural machine translation. This was the first time we actually used neural nets for translation. Then I jumped out of my comfort zone, and I actually worked for the Google Assistant. But I was still working with neural nets, and there is where I also met Hadar for 2 years. And then I missed translation so much that I actually went back to Google Translate. Currently, I'm the head of Google Translate research there, and I'm also co-leading the Gemini I18N effort. Like Hadar said, like, through I18N translation is one of the main tasks there. All right, so let's go a little bit into the background. I was asked to give a little bit of background what is the current state of machine translation. This is a little bit dry, but I think it's honest. So we started back then with rule-based machine translation, where we really come up with linguistic rules. Then example-based machine translation, where we got a query. We had a big database where we actually looked up similar sentences, and then we tried to refine it so that actually we get like a translation. Then this was also the time where I started working on machine translation, statistical machine translation, where we built like big phrase tables of like phrase pairs that could mean the others. We also introduced like probabilities to the whole translation process. Then in 2014, 2015 around, we went to neural nets, which was quite exciting for the field because statistical MT was basically not really improving since many years. A lot of people tried methods, but it was not really improving that much. But neural MT was very exciting. So we built up the new models, and we basically did all the foundation for what we now know about like LLMs. Right? So everything that in LLMs is successful, we actually tried, including at Google Translate on neural MT. And then since probably 2023, LLMs are dominating the field. You're counting? All right. To let everyone know, okay, what is the status, I quickly introduced WMT. WMT is a yearly conference on machine translation. This is happening since 2006, started as a workshop, is now a big conference. Everyone who actually works on machine translation attends this. There are a lot of research papers that focus really on machine translation. It's a smaller community than like the larger ACL or NeurIPS communities, and everyone is like from the field. But the most important thing is there are several shared tasks, so where people can actually submit translations of like test sentences, of new test sentences, and we can compare like how do different teams actually compare to each other, how well are LLMs, how well is Google Translate compared to everyone else, right? So we have like a general MT task, which basically compares different MT providers and researchers who build their own system, and then we also have a metric share task. And I saw in the slides or in the program from last day that Adam, I think, talked about like a metric, so I also included this to give an overview of this. And yeah, so let's jump into this one. So the titles of the findings papers are probably more than enough to show you where we are. So the finding of the 2023 Conference on Machine Translation, the title was LLMs are here, but not quite there yet. So that means like LLMs were producing reasonable translations, but they were not good enough, right? Which also started like encouraging me to work on Gemini 18N. Then in 2024, the title was "The LLM Era is Here, but MT is Not Solved Yet." So this is a big animal in the room for the machine translation community. Is translation already solved? Can we basically close the doors and say, okay, machine translation is solved? In 2024, we said like, okay, they're pretty good, but it's not solved yet. 2025 results, and this is something which is not published yet. It will be published in a few days, but you get a peek into it. All the submissions for, we always cover different language pairs. I put like 2 language pairs there. There's no particular reason why I picked these. All of the submissions, including like the public systems that we actually crawl, are LLM based. There's not a single MT-specific system that actually ranks on the top systems. So LLM is really dominating. We have either, you see like here, for example, Gemini or GPT-4. We also have Claude, how well they are actually doing. But then we have also a lot of submissions from different groups around the world, which specialize different open, accessible LLMs towards machine translation tasks. So they are smaller, they are faster, more efficient, and sometimes even outperform like the general LLMs. So LLMs are dominating the field. Another interesting study is this. This is a paper from us from last year. Is we compared across like 55 languages what is the performance of the best machine translation system compared to a reference translation. A reference translation is human-generated translation, or even a post-edited translation. So we have an initial human translation, and we ask another human actually to correct it. And these are automatic scores. Higher is better here. You see that across the board that actually the automatic scores suggest that the best machine translation system is better than the human translator. There are a lot of caveats on this one, okay? I'm not saying like machine translation is better than the human translator, okay? First of all, this is what we do in the field. We give someone a random text and say like translate it. And there's no purpose behind this, right? It's not like, oh yeah, here's the New York Times article, please translate it so we can actually deliver this to a user in a different country. It's just we ask like random professional translators. So I think it's not even like the average quality of a professional translator. Also a caveat is these are automatic metrics. Automatic metrics are extremely good at predicting the overall quality, but they are not perfect.
Translation, there's the human translation, and then there's someone who's ranking them?
Yes.
And the someone who's ranking them is not a machine?
In this case, it's a machine. In the previous one, it was a human. Sorry, I should have added this. All right. So one of the big questions we currently have in the field is, with current technologies, is it possible to automatically translate and publish high-stakes content such as New York Times articles, medical reports, or UN documents? Because like quality is extremely high for a normal user who actually wants to get an understanding of an article or any other data set, it's good enough, but can we actually serve it? And this is currently what the field is working on. And this is like the quality that we actually operate on, let's say, the top 55 languages. And quick comment to the metric share task. So how well are automatic metrics already predicting the quality of different MT systems? So how much are they correlated with humans who rank machine translation system? And in the presentation from yesterday, we talked about QE, quality estimation models. So we don't need the reference translation, right? We just ask the LLM, here's the source, here's the translation that any system has produced. How good is it? And you can clearly see that the QE models are getting much, much closer to the non-QE models, so the start one, the QE models. These are the non-QE models. So they're getting very, very close. They're almost there. But then when we apply the same for like low resource language pairs beyond like, let's say, the 200s, 400s, 500s language, it's not really working. So because the quality of an LLM, how well it can actually produce a translation in a particular language, is highly correlated with how well it actually can rank translation and assess the quality. So even though this looks like beautiful on the head languages, it's not as beautiful when you go down the tail. Okay, so what's next? So this is my last slide for the status of machine translation. One of the things that the community is working on is challenging data sets. So for example, we are pretty good at translating news, at translating Twitter posts, but there could be medical records or other domains that we haven't figured out yet. But we're basically trying to find like areas where machine translation not excels even for the high research languages. Then we talked briefly about like human and automatic assessment. And currently the metrics don't show what the intuition is of like humans using machine translation. They still say, okay, there are a couple of errors, even though humans actually think it's error-free. So this is something where we basically have to work on to basically claim success that actually machine translation is solved for a particular language. And then, and this is more relevant to here, is more languages. Even LLMs only work well on the top 50 languages or so. There are over 7,100 in-natural languages, of which only half even have a written form, right? So all the languages that we actually worked on in the last years, we have a lot of parallel data, so examples how humans actually translated it, plus it's written, right? So there's a lot to do, right? We are not even there. And then obviously the next step could be non-human languages. All right, so let's talk a little bit about this. So unsupervised machine translation and LLMs are quite related to it. And I heard a lot of these statements in the last years which people said about unsupervised machine translation. They also say about LLMs. And I wanted to clear out a couple of these assumptions. So unsupervised machine translation, I was right with 2018. It was quite popular between 2018 and 2020. And all these methods are mostly based on word embeddings. So meaning a word in a specific content in any language is very similar. So for example, like I said, I'm from Germany, and then maybe French. The countries are next to each other. They actually talk about the same thing. The grammar structure and everything of a sentence is very similar. So when you see, for example, Herr Obama and you see Mr. Obama, it's not so difficult to figure out that Herr is a translation of Mr., right? So what you see here, you actually come up with embeddings in two different languages. The structure is very similar when you train it on a lot of monolingual data, and then you can build a projection so that actually you can see, okay, what this word means is basically a translation in the other language. But this only works because these two languages are very related to each other and they actually talk about exactly the same things. There's popular unsupervised machine translation models which actually started with parallel corpora, so they actually talked about exactly the same things in two different languages, and then they split it apart and made like monolingual corporas and trained these unsupervised machine translation. This is a little bit synthetic because then it's not even that the languages are related, they're actually even talking about exactly the same things, the same sentences. But then follow-up work actually showed, okay, when we start with Chinese to, I think it was Chinese to English even, which already uses different scripts, and you use like very clean, different monolingual data, the whole unsupervised machine translation approach does not really work. Yes, so the question, the open questions after all these works was, to what extent does the LLM-based translation approach perform for isolated languages, right? So if you have like a language that actually has no connection to like, let's say English, how well could we actually do unsupervised machine translation? And now I want to switch a little bit to LLMs because exactly the same statement I heard about LLMs as well. So are LLMs really only trained on monolingual text, or is there some bilingual signal, right? So this is a paper that we did on Palm. Palm was the first language model that we actually published and made open source with Google. And one of the things that we said that several other large language models, such as GPT-3, have demonstrated some capabilities in machine translation despite not being explicitly trained on corpora of parallel text. And we wanted to challenge this statement. So what we wanted to see, we took all the training data where the LLM is actually trained on and wanted to see how much parallel signal is actually already provided in this monolingual training data. So what we did is we looked at all the training examples and we ran language identification over the whole corpus. and cooked each, and basically downsampled it to the documents that included more than one language. So in this particular case, we have a little bit of English, then it switches to German, then it switches back to English, right? So there is some multilingual signal already in the training data. And then we figured out that around 1.5% of the training data actually has this bilingual signal already. And in total, it's around 37 million sentences. So now the question is, what type of bilingual data can we actually find? And we have two different high-level categories, non-translations and translations. So non-translations are, for example, code mixing, right? We have some text in German, and then we switch the language and go into English. And then we go back into German. So this is, I think, is a chat messages between like two humans in different languages. So this is called code switching. It's not a parallel signal, but like I was saying before, they're talking about like similar things. So you can actually get these same understanding bilingual signal as we see in unsupervised machine translation. References to books or movies, the title is in a different language. Right? It's not a translation, but it's a bilingual signal. And sometimes there's even completely unrelated content, right? There's something in one language and then just something else in the other language, because this happens to be crawl the internet, right? It can happen. And then we also have actually translations, right? So, which is like here we have the same text in English, and then we have the same text in German. And this is like the training data where LLMs are based on. So there is no magically translation happening. There are the reasons why we actually get these multilingual signal. And this can be on a paragraph level, or it can actually be on a sentence level, and it can be implicit. And so what are the types of bilingual contamination that we see? We have translations and we have non-translation. And actually we figured out around 40 million parallel sentences are actually in the full training data when you actually tried really, really hard to find it. If we retrained the LLM by excluding this data, it was not really able to translate anymore. So bilingual examples and or anchor points, how I call this, like Mr. Obama. Obama is an anchor point because it's exactly the same word in two languages, are actually necessary for seeing these bilingual capabilities. So what should we do in the absence of any bilingual text or signal? Multimodal. And I think I heard a lot of interesting talks in the last 2 days covering this. So leveraging multimodal inputs for cross-lingual parallel signal creation. So for example, we have two images, 2 sperm whales and a squid, and 2 sperm whales and an anglerfish, right? And so you can already, if this would be different languages, you can see that we can use the images as like the medium between like 2 languages. So open questions that we have not looked into, but we should definitely do, is can we actually translate between languages without any bilingual text signal? For example, an experimental setup, very different than what we currently have. It's very difficult because you actually have to exclude all the text data. So for example, a new created language could be a good candidate for these kind of things. It's very difficult, but it's not impossible. All right, switching gears a little bit. I wanted to tell people about like evaluation, because I think this hasn't been addressed too much in the last days. So one of the main driver of the success of machine translation and LLMs is really evaluation. All right? So what does it mean? So we have to evaluate how good the model is actually at a specific task. Right? If we cannot tell this, we cannot make any progress. So this is a made-up thing. All right? This has no real data to back this up. But this is basically my experience what happened since I entered the field. Right? So at some point, a new metric was invented, and the quality of the system improved dramatically. And then, and this can be months or years, then we saw like minor improvements. And then at some point, it saturated, right? People were trying to come and improve the machine translation system on the current metric, and it was not really improving. They maybe improved the metric, but this was not like really improving the translation quality. And then someone invented a new metric, and we improve again, and the new metric. So one of the main driver of the whole thing is really the eval, so the metric. Otherwise, we cannot improve. And there are two popular sayings, and I want to challenge them now. So the first one is, what gets measured gets done. 100%. And in the LLM era, it's quite true, because there are so many people working on this, so many smart people. And if you give them a task and say like, oh yeah, this is a new task. We want to understand whales, right? And this is how we evaluate it, right? We have a test set. I don't know how we should come up with this. You are the expert for this. But if we have this, I would say like it takes like a month, and we know how this is working when we have the right evaluation. Probably that's quite challenging to start with. And so the next thing is, what you cannot measure, you cannot improve. And I think this was true for a long time. But nowadays in LLMs, I think this is not true anymore. Meaning, there are so many, LLM basically covers so many different capabilities that when we improve some of them, we can actually improve others as well, right? So it might be, if we have the right data and we actually have no idea how we can actually evaluate the task, that the LLM still learns it. So what I'm saying with that is, if we have something to measure, I think we make rapid progress within like weeks, really weeks. But even if we cannot measure it, I think there's a good hope that we can actually end up understanding things that we cannot really measure. All right. Something related, and which I also wanted to talk about briefly, is we have a project since a couple of years, which we called NTL, Next 1,000 Languages. And this is really building machine translation systems for the next 1,000 languages. All right? So this is not only focusing on the head 50, 100 languages, it's like adding more and more languages. This is the effort of build practical machine translation system capable of translating across over 1,000 languages. And most languages are only based on monolingual sentences. When we train them, when we evaluate them, we usually have like parallel examples. We have a paper, I linked it here, I can share the slides later, that includes a lot of interesting failure modes that can be traced down to the reason of training only on monolingual data, where we don't have parallel signal, because the languages are actually not so related to each other as like English and French, and German and French, and German and English. For example, my favorite colors are red, orange, and yellow. Can be translated then, will be translated into my favorite shades are gray, gray, and gray. Because maybe the language doesn't have like an understanding of colors, right? Others, we call this the alligator problem. A lot of languages are mixing up the animals. So we have, I believe a lion is stronger than a tiger. I think hyena's hotter than an elephant, right? And this actually happened across like many of these low resource languages. And this is because we don't have like a parallel signal, and maybe in one language we see a lion, in another language we only see a tiger, right? But you never saw like a tiger or a lion in the other way around. So there are some risks with only doing this with monolingual sentences. All right. Summary. So translation quality dramatically improved over the last 2 years, and people start really talking about parity with humans for the top 50 languages. Probably in a year we are talking about parity of like the next 100 languages. Unsupervised MT and LLMs rely on bilingual signal in the training data. So it's quite challenging to just add a completely unrelated language and hope that it will just magically emerge. But parallel data does not need to be aligned before training. So we saw this. It could be in completely different format. It can be code switching. It could be completely different. Images or videos might serve as an alternative bilingual signal, which I think is great. And on multimodal capabilities, we should all work further, because I think there's a lot of hope for these. But just getting more data can actually be misleading. Because there's a lot of saying about like, okay, we just have to scale up the language model. We just have to get more data, which is true. But I think if your budget limited, you can actually create a data set that is more focused, right? When you really want to someone said like, okay, maybe this was today, can we throw a ball into the water, right? And then we throw a red ball, and then we throw a green ball, right? Like getting like these bilingual signal a little bit more focused instead of just adding more and more data can be a way for the future. And then evaluation is and was critical for the progress of machine translation. If we can come up in some way like an evaluation for, let's say, whale translation, dolphin translation, birds translations, that would be extremely helpful. If not, I think now is the time that we can actually get great progress even without evaluation. And then I used Gemini to say, can you generate a video of two sperm whales saying thank you and happy to take any questions in whale language? Let's see how this. Who knows? Maybe Gemini already knows it. All right, thank you.
Yeah. Thank you so much. Any? You want to start with the question?
I guess your example, so first of all, you're telling us there are no miracles. Mm-hmm. So it's not true that you could just unsupervised translate without parallel. But you could maybe have something where people are switching from English to German and back and forth in some even unaware way. So in terms of the whales, if you could somehow get them to speak, maybe not in English, but in dolphin or have some mix. I don't know how you affect another species to start adopting a language, but.
So you're saying you basically have code matching between dolphins and whales?
How do you incentivize double, what do you call that, bilingual corpuses?
Code switching.
Code switching.
Yeah. I think for animal translation, because we cannot talk to them, right, it's very problematic. And does it really help us to have code switching between dolphins and whales? Maybe, because if we add like...
Well, then you could at least translate between the two of them.
Exactly, but then transfer learning comes into play, right? So then you have like a lot of dolphin data, you have a lot of whale data, then you have like the middle ground, right? And maybe you add more animals, so you actually can get more data and more diverse data, yes. But I think multimodal is really the key behind everything that we can do with animals.
I was wondering if you think that some of these mistranslations, like not being able to disambiguate the animals, is like a fundamental thing or a point-in-time thing? Because you can imagine, you know, you're not afraid of a rabbit and you don't ordinarily eat snakes and things. So like when you start thinking about these words in other contexts, they don't make as much sense in really any language. So exactly. I wonder if it's like these systems just aren't, I don't know, really chasing down the consistency across the entire data set in the same way that you could probably if you were a detective.
Yeah, I think so. I think it just can have a completely different meaning, or something is, like you're saying, you're eating a snake, but in another language you'd never eat a snake, right? And so you will never come up with like these parallel translations. So then you need like humans to, and this is called translationese, where you basically translate something even though it doesn't make much sense, right, into the other language, but you never see like a monolingual example. And so this is the main problem of that. And I think when languages get more and more different, because there is no overlap in what people speaking these languages actually observed during the day, then these methods will fall apart.
So you do think it's like more fundamental?
Yes,
rather than, yeah.
I do.
Thanks.
Oh, go to you first.
Thanks for a great talk from both of you. Quick question: have you ever tried? There's a database of human whistle languages, and I'm trying to think of like a hybrid between what you're doing with human spoken languages. They're spoken, and there are about 90 places in the world. There are 90 whistled languages based on spoken speech, and a lot of us have talked about, you know, could we translate a human whistle language? We could test the efficacy of looking at these components. Would that be helpful? And then we also have, a lot of us have training data. Denise has it. We have it on when we're using artificial codes and seeing how they're using these artificial signals in with their own. I keep on thinking these could be useful. Would that make sense?
I'm not aware of anyone tried this so far, but I think it makes a lot of sense. So if you think about, also regarding the multimodal aspect. Like a couple of years ago, it was clearly hanging behind. So we really needed only text signal or we were requiring text signal to make progress. But now is the time to actually explore these kind of things. So any corpora that is available where people can actually try these kind of method, we should definitely try. And there was never a time that it was so easy to actually do it.
So I'm really curious about the bilingual question, and I agree with you, multimodality is important. But if you had, I don't know about between whales and dolphins, but if you had 2 or 3 species of dolphin, and if their social structure was very parallel, and if they theoretically talked about the same things, raising kids, fighting, where to go for the next meal, and you used those as your bilingual inputs, do you think that would be worth approaching that just from the, dolphin sound, dolphin species 1, dolphin species 2, dolphin species 3? I mean, I imagine you'd probably get some natural, sequences that might parallel, but do you think you could actually, I know it's not a Rosetta Stone because you don't really have a translation, but would that be a way to kind of push it forward a little, so you're not just looking at like one species and trying to figure it out? You've actually got underwater video and sound from 2 or 3 species.
So you're basically saying, okay, instead of like having only one family of dolphins, we have 2 families.
Or different species, yep.
Yes,
and a lot of
get,
nice data.
I think it will definitely help to increase like getting more data, right? It will be easier, but I think they're still missing like the connection to like the human world, right? So, right, you can, then maybe it helps like to translate between one dolphin family to the other dolphin family, and then once we figured out how we can actually translate it to like say English, right? We have more data, we have hopefully twice the amount of data, and we know, okay, how to align actually these dolphins with this parallel signal. That would make things definitely easier, but we're still missing like the connection to like the human world, right?
You want to follow up on that, please?
Well, I'm just thinking that they have parallel lives, and maybe one species would chase one kind of fish, another, and maybe that's where you would get some kind of word breakdown or
Yes.
some detailed, we don't even know if they have words, right? Hello. So, I don't know, I was just thinking it would maybe kind of help us.
Okay, yeah, I 100% agree. Now I got it. Yeah, definitely, it would be cool if there's only like small difference in the speaking, and then you can actually train a model that goes from dolphin 1 to dolphin 2. Then maybe that helps us to nail it down and really understand it. Yeah, yeah, definitely.
First, thank you. That was a beautiful talk, and I like your introduction where you frame that. You kind of first people thought this idea was crazy, and but then they came back to you a day later. I think we feel that a lot in this community, and and it seemed impossible. Now it's seeming, but I like the idea of evaluations that you're thinking about. That's like how to evaluate it, but coming to this from so much human data now and so much experience, like you mentioned that it's not necessarily the data set size, but what would your dream data set if you just had a hypothetical data set now for whales? You could snap your fingers and it would exist. What do you see, envisions in your eyes?
I think I only see this from a simple point of view, and probably this is completely stupid, but like really the throwing a ball into the water and basically making a small difference in like, so for example, machine learning is based on pattern recognition, right? So which means like we want to investigate and figure out like pattern between like different sentences in our world, right? So which means like Mr. Obama and Herr Obama, and then we see the pattern, okay, this one is Herr, the other one is Mr. And you can also do this with longer sentences and paragraph and so on. And if you do like a lot of data, then you actually have more success in finding and figure out the pattern, right? So for whales, it's really like, a lot of people I talked to during the last week were said, like, why whales? It's the most complicated thing, right? And I think there are good reasons for why. But if you have a dog, for example, it would be much easier to, I don't know, throw a red ball, a blue ball, and these kind of things, and come up with these situations that are very similar, and where we know where the difference is and how the animals then react, right? And also to scale this. And so the ideal data set would probably be something that is very focused on like small differences in the environment, and then we can compare and see how the animal actually react on this.
But that might get you to throwing a ball at first word, but then how would you go from there to a complex, a complex communication system?
Yeah, I think this is so. And an LLM nowadays is based on two different things. The first is like an understanding, for example, a word-to-word translation, and then the other one is like how actually is the grammar and the communication of the target language, right? So it means like, okay, ideally we have a larger corpora of like, let's say, whale speech, which we only need to see, okay, what is the next whale word or whatever segment comes up to basically be able to communicate like a whale, and then the understanding just needs like these patterns, right? And the combination of these would be ideal.
Thank you.
All right, two things. First of all, I highly recommend reading Consul Bajakov's book, Chasing Dr. Dolittle, where he actually takes his prairie dogs, the wild prairie dogs, and then between two blinds will bring different objects of different colors and see how it changes their alarm calls. And so that data set is pretty much precisely what you're talking about. The second thing is, I think where Denise is going with this, with her question, is there's situations where she has both bottlenose and spotteds doing things like babysitting for each other. And in her data set, she's annotating all this stuff. So she has human annotated data of two species interacting. And that's, I think where she's thinking that maybe that can be the anchor that helps you out. Yeah. So it's not as clean as the Consul Bajakov stuff, but at least it gives you that anchor in the real world.
Oh yeah. So how can like the community get access to these kinds of data sets?
Talk to her.
Okay. So most of another progress, something that was also necessary to make the progress, is like the work on like open data sets, right? So that we actually, as part of the WMT, for example, the conference on machine translation, where we crawled and provided like the parallel sentences to the community, where basically everyone in the world who had access to a machine could train a neural machine translation model, right? So if we make like corpora available, the corpora that you actually discussed, I think a lot of people would jump on this.
You have access to it.
I had a question. I was thinking that in addition to translation, another great way for a machine to learn about a language that we don't understand is just chat, right? So ChatGPT isn't a translation engine, but it succeeded at engaging humans in dialogue, right? And so it seems like maybe a different path would be not through the model of the translate, but just the model of, can you build ChatGPT for animals and find a way to motivate them to engage, and then learn from how they use that to build an understanding of the statistics of their language, and maybe long before you even know what it means, if you could build something that they engage with, you might be able to come to understand it. And we're trying to do that with birds engaging, with iPads and like robotic agents that get them to, communicate. But you could see that happening with whales in some context. And I was just curious your thoughts on that. If is there a very direct connection between like translation efforts and chat efforts, and do those, could you create chat bots for languages that are under-resourced and just get people to like effectively engage in the ChatGPT for that language, and then create a translator based on the statistics that you learn from, from the chatbot?
I think that's an interesting question. I think for humans, yes, because they're like word frequencies are very similar on related languages, right? So there you can come up with some assumption. I mean, this is also one of the basic approach of like these unsupervised approaches, that you first understand like the most frequent words, and then you can basically build up. And so that lead-chain interface could be quite helpful. I have trouble to understand or to see the direct connection, how you can actually then understand the language. I think it could be multimodal, and then it would be interesting with this chat. But just by recording and having like two animals talk to each other, but because we have no idea what they are actually talking about, right, and how they actually talk. And
well, I think what we're specifically interested in is developing agents that engage the animals. So the the bird calls, the agent learns, okay, if I call with this latency and this sound, I'm likely to get a response. And it's essentially doing reinforcement learning on maximally engaging communication.
Right.
And then you start to build out rules that say, okay, this kind of call has to be followed by this kind of response with this kind of latency in order to get a probable ongoing engagement.
I think it will definitely be super helpful also to like generate more and more data. But at some point we have to have a connection to the real world, or not to the real world, to the human world, right? So giving some kind of connection, I think this data could be very helpful. I mean, this basically enables us to generate more and more data, right? And basically target what we actually want to hear, right? We said like, okay, we have no idea what this actually means, so we have this chat bot, which we can basically let communicate to birds, and then we get more data that we actually get, especially more data for the things that we don't understand. But we need some grounding to start with. Yeah.
And then I wonder, for human languages, if you could you build a chatbot for a language that's just completely, there's no translations, and it's completely isolated language, or you could successfully build a chatbot and then say, does that help you to create a translator with very small amount of data once you know the statistics from building a successful chatbot for this language spoken by 100 people in the Peruvian Amazon?
Yeah. So this is something which I really want to look into in the near future. So we had one project, there was one project in the machine translation community who tried to translate from one grammar book. So they really took a language that with high certainty was never been seen by the LLMs, and can we just use a grammar book to actually learn the language, right? So this is the closest to these kinds of efforts as we got there. And it was possible to, based on this one grammar book, to actually do learn the translation, at least understand it a little bit. There was some follow-up work that actually said, okay, the only necessary part of it was just the parallel signal. So the bilingual signal again, and the grammar rules were not so important. But this was something that is the closest to what you actually proposed that has been done so far. But I would be really curious about like trying something that is completely unknown for like the LLMs, maybe even like completely unrelated to anything there, and then experiment on this one. And maybe even find, maybe it's easier with like a completely isolated language to start with than even with animals, and maybe that's the intermediate step.
I wanted to echo something you said and advance what might be a slightly unpopular opinion now, but maybe growing more popular over time. So 5 years ago, the idea of just giving wholesale data sets to Microsoft or Meta or somebody else was completely unpalatable. Never happened. We might work with small distinct groups, Microsoft's AI for Earth team, et cetera, but nobody wanted to give away to a large corporation. What's evident throughout the 2 days of the presentation is we're all using open source LLMs or proprietary LLMs, but they're embedded, and our species are highly, unrepresented or minimally represented in all of them. And we're at Conservation X Labs. I can't talk in specific details, but we're starting to share with permission some of the camera trapping data and segmentation values from it without a distinct purpose of this is going to benefit us immediately, but this is going to benefit us long term, because we are using the models being produced by these vendors. And it's interestingly a way of capturing the expertise that's in this room, the wisdom and experience, all the judgment that's gone into curating these data sets, capturing that personal experience and judgment for future generations. The next group of presenters next year and 5 years that are using LLMs will then be building on top of the solutions that you've shared data for, and that these companies who will incorporate it. My experience working with some of these large corporations developing these models is that they're really nice people and really excited about the wildlife data you bring them, because it's so much less boring than the other things they train the LLMs on. So I highly encourage you to think about, just for future generations, for capturing your expertise, to really think about what, and this is gonna sound weird, what could you share with a major corporation that would benefit you in the long run and next generations of researchers? So, thank you.
I think we'll do one more. Oh.
I was just wondering, since you work with all the language translation, do you also try to find about the evolution of language through the ability, the success in translation? Because I assume that languages that evolve from each other will be much easier to translate.
Oh yeah, yeah. So what we had like back I don't know 5 years ago, we had like always bilingual machine translation system, which can only translate from one language to the other. But then we basically grouped languages together, right? So something that is very related to each other, especially when you go into the low resort languages.
This is from what you know. The question is whether you can deduce from your success.
Yeah. Sorry, say again.
This is what you know, but
Yeah.
I'm answering whether you can make deductions from your success as to what the evolution of languages are, or is that just everybody knows anyway?
Oh.
I don't know that anybody looked into that specifically. I mean, there's also a lot of folklore that interferes. Like, languages don't develop in isolation. They also come in contact with each other, and you have a lot of leakage of one language into the other. And it's a messy process that causes languages to change and evolve. But I don't know of anybody who looked at it specifically from that perspective.
Can you predict how language will evolve?
That's a question, I guess. This is just piggybacking on the idea of having similar species of dolphins. You would still have the problem that they're not aligned, right? If you have different snippets of sound. And I was wondering whether your idea of, using sort of multimodal data sets could be a way to bridge it, because you could align the videos of the two, for which we have better understanding of what's going on, and we can actually try and extract behaviors that are similar across them, and then align each videos with their own sounds.
Yes.
And at the point you bridge through, would that be something that sounds more reasonable?
That would be definitely reasonable. I think this is the way to go. Yes.
Anyway, thank you so much. Wonderful talk. Really appreciate it. All right.